Hello, everyone. Yay, math. All right. Calculus. We got two big theorems here we're talking about today and looking for how to tell them apart. The intermediate value theorem, if you remember, that's the one where if the function is continuous, it's got to go through a certain number. The question is, what are the conditions that we have to have? Well, the conditions were f of c has to be between f of a and f of b. Now it could be also be reversed. But f of c has got to be between the y values for the endpoints. And f of x, f must be continuous. Continuous over the closed interval. So those are the two big conditions. Whatever number we're looking for, it's got to be between those two, and f must be continuous over it. The condition for the mean value theorem, f is continuous over the closed interval a to b, and f is differentiable over the open interval. Okay, so we've got two questions here. They look very, very similar. This one we said, this one's got bug is walking along the x-axis, bug's velocity is continuous and differentiable, and the selected values are given in the table above. This is the same thing. This one though, is there a time c such that for c is between 1 and 5 such that the velocity v of c is equal to 0? Here it's asking for, is there a time such between 0 and 9 such that the acceleration is equal to -1? So how can we tell which one's which? Well, there's actually a key to it. Here we're given the velocity and they're asking us to find that velocity when the velocity is 0. To give us the velocity, we're asked to find when the velocity is 0. Over here, to give us the velocity, and they want us to know, they're asking us, is there time when the acceleration or the derivative? So what do you look for? If f values are given and you're asked to find f, here f values are given and you're asked to find f prime. In this case, the derivative velocity is acceleration. So, how do we answer these? That's the big question. When you're given a problem like this, first thing to do is identify what is the question asking. Is this an intermediate value theorem question or a mean value theorem question? Then, when they say give the reason, they're wanting you to explain your answer. I'm going to show you exactly what the readers are looking for. Let's start with the work here though. From 1 to 5, is there a time between 1 and 5, somewhere in here, such that v of c is equal to 0? Well, let's look. We're going from 2 to negative 7, right? Okay, so you can just say, hey, you're going from 2 to negative 7, so therefore there's got to be a time. That's not quite enough, though. What we need to do is show the work and make sure we satisfy all the conditions. Then we're going to restate, and that's giving our reason. So what we can do is we're going to show f of 5 equals negative 7. F of 1 equals 2. Sorry, I shouldn't use f, I should use v. V of 5 is negative 7. V of 1 is equal to 2. 0 is between V of 5 and V of 1. So we've satisfied this condition up here. It's 0 is between the two y values at the endpoints. We also need to say that the function's continuous. Well, the velocity is continuous. So what we're going to come down here and say is, since v is continuous on one to 5, the intermediate value theorem guarantees that. Then we're just going to restate exactly what was written up here. Don't screw with it. Don't try to get around it. Just restate what's written up here. Guarantees that there is a time c between 1 and 5 such that v of c equals 0. If you want to, add that. Don't try to get fancy. Don't try to cut corners. You show the work. 0 is between v of 5 and v of 1. That's v of c. Show that you're satisfying the conditions. It tells us, since v is continuous on the closed interval, the intermediate value theorem guarantees that there's a time c between 1 and 5 such that v of c equals 0. Just restate it. All right. Over here, mean value theorem. We know it's a mean value theorem because they're asking us for acceleration, but they gave us velocity. So one of the first things I'm going to do is I'm going to say v prime of t is equal to acceleration. I'm going to state that right off the bat. Now I'm going to mess around with it. That way I've shown them I've made the connection. So what do I have to do now? What work do I need to show? Well, I need to find the acceleration. They don't give us a function, but I'm going to find the acceleration over 0 to 9. So I'm going to have v of 0 minus v of 9 all over 0 minus 9. This is the average rate of change. Average rate of change. You don't write this. I'm just writing it for your sake. Now, v of 0 is 5. V of 9 is negative 4. If I work this out, I'm going to get 9 over negative 9. And that's going to give me negative 1. We know the average rate of change has to be equal to the instant rate of change at some point. The instant rate of change, in this case, is the acceleration. So once we show this, we make our statement. Don't try to get cute and try to figure out what's the least amount you can get away with. You show that the velocity, the average velocity over the interval, you make it equal to the instant rate of change, then you make the following statement. Since v is continuous over 0 to 9, and differentiable over 0 to 9 open. If you know it's differentiable on the whole thing, then you know it's differentiable on the open interval as well. The mean value theorem guarantees that, and then we're just going to restate it. There is a time for c between 0 and 9 such that a of c is equal to -1. That's all you have to do. Show the average rate of change is equal to the instant rate of change. Make this statement. Again, you have to state that the function is continuous. You have to satisfy that condition. You have to satisfy the condition that it's differentiable. If you don't do that, you're not going to get the point for giving your reason. All right. There you go. Thanks for watching.